Welcome to The Explainer. Today we're going to explore something that every single one of us has to deal with at some point, and that is sharing food fairly. We're going to take a really fun, delicious journey using a highly visual style of math to understand exactly how to split things up so that everyone leaves the table happy. If you've ever worried you're getting a smaller piece of the pie, or, well, in our case today, rotis and chiki, this visual guide to mathematical equality is absolutely for you.
Okay, let's dive right into this. I want you to imagine you're sitting down with your absolute favorite treat. Maybe you're with two of your best friends and you need to split what's on the plate. How do you make sure nobody feels left out? How do you know for an absolute fact that the shares are perfectly fair? Well, mathematics gives us the perfect tool for this, fractions. But we aren't just going to look at boring numbers. We're going to visually map out the food itself. Section 1. What are equivalent fractions? The roti rule. Picture a fresh, warm, perfectly round roti. It's literally the ideal shape for our very first mathematical puzzle. Imagine we have exactly 3 children, but only 2 rotis. If we tear these rotis up and share them completely equally, how much does each child get? If you visualize the shared pieces, each child gets exactly 2/3 of a roti. That's 2 whole items divided by 3 people, which equals the fraction 2/3. Simple enough, right? And this brilliantly illustrates our next leap in logic. What happens if another group of friends shows up? We're now comparing our original group, 2 rotis for 3 kids, with a brand new group, 4 rotis for 6 kids. Notice what we did there? We doubled the amount of food, going from 2 to 4. But we also doubled the number of hungry kids, from 3 to 6. Because everything doubled equally, the actual amount of food each child gets hasn't changed one bit. Every single child in that second group still gets exactly 2/3 of a roti. So looking at this sequence visually, if we had 6 rotis and 9 kids, the math stays completely beautifully balanced. 2/3, 4/6, and 6/9. These are what we call equivalent fractions. Even though the numbers themselves are getting bigger and bigger, they all represent the exact same fair share of food. The visual portions take up the exact same amount of physical space.
Section 2. Finding a common denominator, or making things match. Let's see how this builds into our next challenge. What happens when the fractions don't speak the same language? Imagine one friend offers you 3/4 of their snack and another offers you 7/10 of theirs. How can we possibly compare a share of 3/4 with a share of 7/10? The pieces are completely different sizes. A fourth is a big, chunky piece, while a tenth is a much smaller sliver. We really can't compare them until we make the piece sizes visually identical. Thankfully, there's an incredibly simple trick to fix this. Step 1, simply look at the bottom numbers, which we call the denominators. We've got a 4 and we've got a 10. Step 2, just multiply them together. 4 times 10, that's literally it. That gives us 40. This number right here is our new shared base, our common denominator. It's kind of like magic, honestly. It lets us visually cut up both snacks into 40 tiny equal pieces. Suddenly, 3/4 becomes 30/40, and 7/10 becomes 28/40. Because the bottoms now match perfectly, they're super easy to compare. Now you can easily see which friend is actually offering you more. Section 3. Fractions in lowest terms. Keeping it simple. But dealing with common denominators like 40 can get a bit exhausting. Sometimes our math gives us numbers that are just way too big and clumsy for everyday life. Take the fraction 16/20, for example. If you tell your friend you want 16/20 of their sandwich, they're going to look at you like you're crazy. It's a big, clunky number. Now, it's mathematically correct, for sure, but it's not very friendly. We want to shrink this down to make it easier to visualize and understand. To do that, we actually just do the exact opposite of what we did before. Instead of multiplying, we divide. First, we need to find the biggest number that divides perfectly into both 16 and 20. Think about your multiplication tables. What fits into both? The number 4. So for the next step, we divide the top number, 16, by 4, which gives us 4. Then we divide the bottom number, 20, by 4, which gives us 5. So the crucial point is that 16/20 is exactly the same as the much simpler, much friendlier fraction 4/5. It's the exact same amount of food, just described in a way that our brains can picture so much more easily. 4 big pieces out of 5 total pieces. Section 4. Comparing the chiki shares. Who gets more?
Now, with our visual math tools completely sharpened, it's time for some friendly competition using rectangular bars of sweet, delicious peanut chicky. What's really interesting here is how clearly we can answer a tricky question. Which is bigger, 1/2 of a chicky bar or 5/8? When you look at the visual representation, you can plainly see that the 5/8 share stretches just a little bit further than the 1/2 share.
But why does it stretch further? Well, the math here is actually super simple, and you don't even need a pen and paper. Just visualize the fraction 5/8. The bottom number is 8. What is exactly half of 8? It's 4. So 4/8 is exactly 1/2. If you have 5 pieces out of 8, you clearly have more than 4 pieces. Therefore, 5 is bigger than 4, meaning 5/8 is definitively greater than 1/2. Bottom line, you get more chicky.
Let's look at another one. This time, you have to decide between taking half of a piece or taking 4/7 of a piece. Visually, it looks really close, but the 4/7 share just barely edges out the half share. Let's apply that exact same patient, logical thinking here. The bottom number is 7. What's exactly half of 7? It's 3.5, or 3.5. So 3.5 would be exactly a half. But you're being offered 4/7. Since 4 is bigger than 3.5, having 4 pieces, once again, guarantees you are getting more than half the chicky. It's a fantastic little mental math trick you can use literally anywhere.
Section 5. Golden Rules of Sharing. The Sugarcane Juice Test.
To wrap up our explainer today, let's visualize our final, refreshing scenario, sharing sweet sugarcane juice among groups of children. This scenario gives us 2 absolute golden rules of sharing fractions that you really must remember. Here's rule number 1. If you have more children sharing the exact same amount of juice, it means a smaller share for everyone. The denominator gets bigger, so the visual pieces get smaller. And here is rule number 2. If you have more juice for the exact same number of children, it means a larger share for everyone. The numerator, that top number, gets bigger, so everyone's cup gets fuller. Which brings us to the end of our visual math journey today. We've mastered the roti rule, we found common denominators, and we finally settled those great chicky debates. So I'll leave you with this final thought and question. The next time you sit down to share a treat with your friends or family, how will you use your incredible new math powers to make sure the sharing is completely, perfectly fair? Keep visualizing those fractions, and I'll catch you in the next explainer.